Hello, everyone, and a very good afternoon, morning, or evening based on where you are today. Thank you for joining us for the 15th episode of the IET India Digital Conversations. Today's session is on digital twins for secure, green, and healthy future cities and is curated by the Smart Cities Working Group of the IET Future Tech Panel. We have an expert panel with us today from India, UK, and Singapore who have been part of such core systems and will share their key learnings and perspectives in this intense discussion today. I am your weekly host, Suman Bhaumik, and I lead the events development for IT in India. Introducing the moderator for today's session. His name is V. Srinivasa Rao. We all know him well as VSR. VSR is the chair of the Smart Cities Working Group of the IT Future Tech Panel and is also the chairman and managing director of BT and BT. I will pass this on to you now, VSR, as we have a long list of introductions and a huge session to look forward to.
Yeah, thanks, Suman. Thanks for that great introduction about the topic. So this is, I think, a very interesting day. We have esteemed panel from India, UK, and Singapore. So let me set the context before we getting into the introduction of the speakers. I'm sure we have been talking about fourth industrial revolution and digital economy, I think for the last one decade. So we have the technology fusion happening today, like information technology, communications, collaboration technology, and operations technology. So I think the boundaries getting blurred and all this technology fusion is happening. The other greatest innovation happened in the last one decade is the IPv6, which has probably 350 trillion IP addresses. That means literally you can give IP address to anything in the world which can be connected to internet. So with that note, these technologies fusion and also the IPv6 enabling us to give life to things like cars, machine, equipment, or dustbins, or even the baby diapers, or the bed sheets, whatnot. That means they are able to sense, they are able to think, they are able to communicate, and they are able to predict with the help of these technologies. There are so many twins you can create when the actual data, as I mentioned earlier, the Internet of Things, the sensors, the fusion of different technologies, able to pump the actual data. If I am a human being, the data is coming from my body, what is the temperature, what is the blood pressure and all. Or if it is a car, then the diagnostic details of the car will go to the twin, the equivalent part of that. Then your machine learning and artificial intelligence algorithms will play with that, with the virtual brain, and it will tell, okay, what happened, why did it happen, what will happen. Okay, if it happens, let me give you some recommendations. Don't you think it is highly powerful? So that's where the digital twins are going to play a very vital role. Today, in specific, we are going to talk about the twins. That means how do you create a twin for the whole city or some systems within the city.
Chetan, I would like to bring you up and understand from you what are your thoughts on this subject. I know you have been involved in many of such projects, and if you can just start the session by telling us more about your thoughts on this, and then we can go on to the next set of speakers.
Sure. Okay. Welcome all. And then actually just before the session started, all of the panelists, we were having a conversation on how the quality of connection is inversely proportional to the importance of the meeting. Actually, VSR's connection was perfectly fine. Everything was tested. And then when he came to the right moment, unfortunately, the connection got off. But that's the reality. Now, what do we think about digital twin and digital twin specifically related to a city, right? So my name is Chetan. I'm from Siemens Advanta. So we are the technology wing of Siemens, dealing with digitalization, Industry 4.0, you name it. So what do we have? Because when you hear something like Siemens, it's an industrial house. What do we have to do with cities? Now, I would say there are mega trends, global mega trends. Right? So one is urbanization. We all know for the first time in the history of humankind, there are more people in the cities than there are in the rural areas. Then the second thing is demographics. Like the population is aging. We are hitting 7.88 billion people, and then a bulk of them are in the cities. The third mega trend, which all of you would agree, is the climate change, right? And then the fourth mega trend is about digitalization. Or maybe, like depending on who you talk to, there can be more mega trends, but then these are some of the things that all of us agree. Now, city is a complex organism. It's a system of systems, right? So it's not like a factory, it's not like a building. It's a very, very complex organism. So one, it's certainly a system of systems, and then it's a confluence of all of the mega trends that I just spoke about, right? Be it urbanization, be it the climate change or anything. So it's a confluence. All of them meet at the city point. Then all the cities, irrespective of where they have aging infrastructure, whether it is New York, whether it is Tokyo, London, Mumbai, whichever big city you talk about, the infrastructure is aging. And then the city is also very unique when it comes to its business model, right? So it doesn't have a conventional business model. It's extremely difficult for you to do return on investment, the competition landscape, and so on and so forth. So this is what we look at when we talk about a city. Now that's the first part. The second part is about the digital twin itself. Like maybe where probably the next after the other panelists talk about it, I will put forth my idea of why a digital twin for a city.
Okay, let me start now. I think we talk about the something like the connected world, where the human beings and the other things are getting connected, and having the twins really need of the hour. But city perspective, let me start with Ben. So, what do you think the urbanization challenges in general? So, what are the alarming trends you see, and why we are talking about digital twins today, not in the past? Over to Ben.
Yeah, I think Chetan summed it up very nicely before in terms of the global trends that we're seeing, and I think we're at kind of a confluence of the technology maturing now to be able to support resolution of some of these challenges, or attempt to. And let's not make any mistakes or shy away from the fact that these challenges are very difficult to overcome. So we are going to need fundamentally new tools to overcome these challenges. And I think a lot of people within the industry see the challenges of human communication and communication in general as one of the things that we need to empower and turbocharge to be able to overcome these challenges. So I see very much that digital twins are something that frees humans to spend more time on the harder questions, addressing the complexities of the challenges that we're going to see from these global trends. I think it was probably Steve Jobs that said the computer's a bicycle for a mind, or somebody much cleverer than I, certainly. And I think digital twins are similar in that they allow humans to use their skills to solve greater challenges. So, and that might be automating things that are routine so that they can spend more time doing the things that are non-routine and require more thought. But fundamentally also providing the tools in which to support better decisions. So as complexity increases, we need tools that support and evidence better decisions. So that's what I think we're getting, and hyperconnectivity and the advent of social media and the internet of things are pushing us all in that direction.
Yeah, I think thanks, Ben. So if I just extend that question, today countries like India, of course, I'm sure in UK also, there are so many challenges in the cities. People are moving from rural places to the urban places, and then there's so much of the traffic issues, the pollution, right, and the abundant water availability is a problem, right? So there are so many issues that are happening. So what do you think this digital twin, which we talk about, the replica, of the city or the systems in the city, how it will basically, yeah, I think you talked about evidence-based decisions, and then you can get the visibility, what is happening or not. Such type of major issues, how you can solve with the digital twin.
I think it's all about the decision making. So if we are to improve things like water usage, we have to understand all the connected aspects around water usage to minimize its use. If we want to minimize the amount of waste, we have to look at circular economies. So we have to enable previously unconnected businesses or concepts to understand what's happening in the adjacent space. So it's truly transformative in terms of the amount of connectivity we need to make better decisions.
Okay.
Carry on.
All right. Okay. Thank you, Ben. I think so. What you are summarizing here is, like I mentioned. So it's like getting answers to what happened, why did it happen, what will happen. If something happens, then what we should do in the city environment. So it's a better decision-making tool that digital twins are required. Okay. Moving to Ravi Ramaswamy, could you please share your thoughts on what are the organization challenges you see in India, especially? So what do you think the digital twin, how it will play a role?
Thanks, VSR, for giving me this opportunity to share my 2 cents. If I look at India, it's a completely lopsided distribution in terms of population versus healthcare resources. 80% of the population is in the rural with less than 10% of resources. And if statistics were to be looked at, the urban population is around 85 million with 520,000 doctors versus 830 million semi-urban and rural population with about 65,000 doctors. So basically what we really need to do is to sort of decentralize care to enable the large masses that we have in the semi-urban and rural area to get the same quality of benefits, quality of care that you would get in an urban city.
Okay.
And how do we do that? The question is, we can bring in digital twins, or in its earliest form, what I would call as clinical decision support systems. We will deal with it more as I go into the seminar, but then suffice to say that we could possibly start with the guideline-based interpretation at the earliest, and then build on to AI, artificial intelligence, machine learning, multi-parameter modeling, and stuff like that as we further our development into this place. So basically what we are trying to say is there a way that I can give the same quality of care what an urban person would get at the rural level, and therefore manage footfall as well? So that is something that we are looking forward to.
All right. Excellent. So I think there is a great potential by using the digital twins. You can improve the healthcare of the people. So probably who migrated from rural India and also who are staying there. Thank you so much.
Yeah.
Thank you so much. All right, Chetan. So I think you have done some city projects. I'm sure you might have experienced a lot of challenges in building the digital twin. Can you share? So what are the organization challenges you basically experienced, your team experienced while you are executing the project?
Sure. I'd be happy to do that. So as I was telling in the opening statement, cities are some of the most complex human endeavors, right? And we do not really have a lot of control on how a city is built, how a city develops. Except there is one that's happening in Saudi Arabia. It's called NEOM. It's a city that is being built from the scratch. And it's, I think, something like a $500 billion project. It's the largest project that the humankind has ever undertaken. So that gives you a scale, right? So the second largest project that the humankind has done is the International Space Station, and that I think is like $150 billion or $200 billion. So that gives you the scale.
Dr. Hari, I think you have been into this space for quite a long time. Would like to understand, in your view, what is a city? I mean, I think the speakers have been talking about the digital and all, but I would like to hear you. The city is nothing but systems of systems. So from your experience, what a city constitutes and what challenges people are facing today? Could you please share your thoughts on that, Dr. Hari?
Right. Thank you. Um, so, as you said, we've been in this for some time. So, the idea of digital twin is a very exciting one. It brings the concept of a virtual analog of the physical city. But the problem we find is it's very good to have a digital view of something. But if the physical systems or systems of systems are not working well, then your digital twin will be less than useful. So, very critical and importantly, the value of a digital twin is not just to optimize, manage, monitor, and control your physical twin, but also to improve the way the physical twin is put together. In a greenfield project, the opportunity for designing a city is actually use the physical twin, in a sense, a digital twin, in a sense, as a blueprint for the city. You use it to make the city and then you use it to operate. And this is where we are going with buildings. We're working with buildings and precincts which are not, not the city of Bangalore or city of Singapore, but these are smaller precincts where we're using the concept of digital twin to actually design the city, to build the city, and operate it. And I think that's where the true power of digital twin come into being.
Okay, okay. Thank you, Dr. Hari. So, Vijay, I think could you please share some of the challenges what you experienced in your experience? I mean, throughout your career, you might have been working on city projects. Can you share what challenges the residents and also the other stakeholders have been facing in the Indian cities?
Yeah, definitely. There are multiple challenges. We have seen people facing in growing cities, and as a few panelists already mentioned, people have been moving from villages to the city now, and the city population has been exploding. In fact, and it has to have enough infrastructure to support needs of the people, and particularly in terms of water becomes all the more relevant in terms of ensuring the quality, ensuring the availability, and more importantly, making sure that pipelines and the infrastructure that is laid out to deliver the water are all intact, and there is no loss as such, which we call as a non-revenue water. Those are the major challenges which definitely we have to take into account. So when we talk about the water distribution and the network particularly, these are the areas which definitely need better monitoring capabilities to make sure that the loss is minimized, and we have adequate amount of water that is available for people for consumption 24/7, 365. And I just wanted to take a small example of cricket here, because we always say in the game of cricket that every run that you save is the run that you have scored. That's the notion that we have there. Likewise, water being now such a important resource, the wastage that you avoid is basically the resource that you have created, and we got to understand that, and we got to bring this aspect in the fold of digital twin, and we got to make sure that how digital twin can basically help us to achieve this and overcome some of these challenges.
Excellent. Okay, thanks, Vijay. I think it's wonderful, the summary, like Ben mentioned about the decision making, connectivity. So all these things are very important before we really getting into the spin and all. Then Ravi talked about the health, how to improve the healthcare. Today, a lot of challenges are there. So how the digital twins can be used to improve the healthcare. Dr. Hari mentioned, especially before going to the digital twins, you should understand their parallel, the physical systems, whether if they are not functioning well, there is no point of having the digital twin. And Chetan also mentioned about the trends and other challenges. Vijay, you talk about the water as a challenge. Of course, in this session, it is difficult to cover all the challenges. So now let us all agree that there are challenges, and we all believe that digital twin will play a very vital role in transforming the cities. So I would like to hear from Chetan um, some practical experience. Chetan, I think Siemens has done a wonderful project in one of the, I think, the Gulf countries.
Yeah.
Could you please share in 2 minutes, 1.5 2 minutes, what is the experience you got in managing that digital twin project?
Yeah, I'll try to. And I'm also seeing there in the chat somebody saying, can we start with first principles, as in what is and what is not a digital twin? I'll just take maybe a minute, 2 minutes to kind of do that and then step into the actual thing. Okay.
Yeah.
So the first one, in fact, I had started this. So I would say the digital twins are at 3 levels, right? The simplest is a replica. When I say replica, replica is in two things, right? So one is form, which is basically a copy, visual, 3D, rendered. And then the second one is the functionality, right? So I was just giving an example of an airport. So if you see the drawing of an airport, the elevation, the plan, the layout, etc., etc. So that is the copy of a plan, right? That is form. But the functionality is a little bit more complicated, meaning how many people can come in, how many gates do you have, how many people can go out, does it lead to congestion? If it leads to congestion, what are its implications? What happens to the air circulation, HVAC systems? So there can be a bunch of things when it comes to functionality. Now, so in my 3 levels, this is level 1, form and functionality. Now, the second one is a little bit more complicated, right? So I said in the beginning, this is in the order of complexity. So the second type of twin is for control and optimize, right? So when I say control and optimize, let's take an example of street lighting, right? So you have maybe hundreds of thousands of street lamps. They have to be controlled, remotely switched on, switched off, measure the efficiency, compare it with so many things. What happens when during winters, what happens during summers, the areas where they are not on, off, what kind of power consumption, all that is control, which is typical command and control center. Then it gets a little bit more complicated when we say optimize, right? Because optimization is not just this, but then optimization needs stimulus, right? So when you give a stimulus, it should respond. The system will become more complicated and will start responding to the stimulus or stimuli. So there again, cities are difficult organisms. So if it is a motor, it's a different story. But in a city, this whole response to stimulus becomes very, very complex. I'll give you an example. So in one of the projects that we were doing, we said we can tell you what the air quality is. The city administration told us, that I can do that. I plug a bunch of air quality sensors. I know what is happening with the air quality. But I want your expertise to tell me how to connect these two. And what is the other thing? One is air quality. The other thing is mobility, right? So now I'm sure you guys are following the complexity, the increase in complexity, right? So because now if I add 2 additional cars to the metro system, it will have a direct impact on the air quality, right? Because it's a system of systems. So that is about optimizing. How do we do these things? Now, again, continuing in the same second category. First category is replica, form and functionality. Second one is control and optimize. Now, cities have 2 types of problems: chronic, acute. Chronic is what like Vijay was talking about, right? What's happening to my water system? Will I be able to detect where is the leakage? Will I be able to fix that leakage? Traffic, very good example of a chronic problem. Air quality, very good example of a chronic problem. And then there are acute problems. So for example, the one that VSR was talking about, it's in Middle East, and they said, like, can you help me deal with a sandstorm? Like, you create whatever you want, but can you help me deal with a sandstorm? Mumbai or New York, for that matter, would certainly love if you were to give them a solution on how to deal with these hurricanes or like excessive rainfall in short periods of time. So that is about the acute events.
Yeah,
Now
actually, sorry to,
Yeah.
I think in the interest of the time, what I suggest is, I think
Yeah.
the question is also very relevant from UE. So, can you talk about how you simulated? Let us take one example that
I will.
stands.
I will.
So how you
Let's
simulate?
take the sandstorm.
Yeah, virtually how you simulated, how you able to predict. That's where the twin, right?
Absolutely.
Otherwise, it's like a typical conventional problem. So,
Absolutely.
so then probably we can also get into the principles. Maybe I will ask Ben. So please explain how that is simulated in a virtual world
Yeah.
with the 3D modeling. How do you predicted whether the sandstorm is going to distract? How you are going to take some actions? Yeah.
Absolutely. So, like for those of you who have visited some of the Middle Eastern countries, or, like all of you, I'm sure are aware. So, like there are cities and then surrounded by vast landscape of desert landscape. Now, so the requirement, as I said, is can you predict, one, will the sandstorm hit us? If so, BSR, to your point, how should I respond to that? Right? So this is the problem. Now, the first thing, obviously, the data comes from a bunch of sensors. Now, I'll just keep it very simple. I know we are racing against time, but then I'll keep it very simple. The first one is a silica sensor. So primarily, what does it do? It does sample the air and identify the silica particles, the concentration of silica particles. Very simple thing. The second thing is about the visibility, right? So let's just stick to these 2 points. I'm just oversimplifying the whole thing. But then two sensors. One will recognize the amount of silica in the air, and the second one will detect the visibility, right? So you create a digital twin. When I say digital twin, and then just reinforcing this thing with the audience that it doesn't really look like a city, right? A digital twin might look like a physics model. Like Hollywood actually kind of has distorted the image of digital twin, that it always looks like a 3D image. Might not always. So now, so we put silica sensors probably 30 kilometers at the periphery, and then also have the sensors that measure the visibility. Now we have the day's prediction from the satellite system. We have buoys which identify the wind direction, right? And then we have the algorithms which actually have the historical data. Now you do it at 20 kilometers from the city, or maybe 40 kilometers from the city. You have all of these as data inputs: the data from the sensors, the data from the satellite image, from the buoy about the wind direction, and your algorithms, right? So all the four are working together and then start giving you a probability. So when you detect some activity at 40 kilometers, it says there is a probability of 25% that you are in the path of a sandstorm. Now we have a similar setup simulated probably 10 kilometers or 8 kilometers away, right?
Okay.
So if you see that, probability goes up. And then one last point, and I'll end it, VSR.
Yeah.
Now, what do we do? Right? Yeah, so it's fine. Yes, it's not fine, but then, yeah, there is a sandstorm. But then what do? Then we connect the HVAC systems. There are canopies that we deploy so that the HVAC systems don't suck in the sand, right? So the systems will be stopped. The obstacles will be introduced so that, you not only predict, you not only tell them in advance, but you also take actions to stop it. Yeah, sorry.
Excellent.
Yeah, I took maybe more time.
I think it's excellent. In fact, a lot of great information we are able to derive within a short time. So the whole crux, what you are saying is from the physical world, through sensors and other systems, you are getting the data in real time. And then the simulated virtual model of that particular city in the context of this sandstorm, the data is pumped, and with the machine learning algorithms, that simulated whatever the model is speaking and saying this is the place where it is going to be problem. You need to take decision. Thank you so much, Chetan. So now let me get into Ravi, because health is very important. So Ravi, I think you can really give a better example also, because people can understand. Can you create a twin for me, Ravi? Is it possible?
Absolutely. Suman, can you play the video for me, please?
Yeah. Some people said you can talk to the twin, you can even the person leave this world.
Look at this, please.
Imagine a future where personalised healthcare will provide every individual the right type of care in the right way and at the right time. Imagine that every patient has a digital twin, a virtual representation of his health status. Let's explore how this could play a significant role when Mr. Clark, who has been diagnosed with atrial fibrillation, is seeing Dr. Sullivan, his cardiologist. Although AF is a highly prevalent disease, it can be complicated to decide on the individual treatment strategy for a patient like Mr. Clark. This is where his digital twin comes in. It starts by using Mr. Clark's medical data to create a patient-specific biophysical model, including a virtual version of his heart, which looks, behaves, and reacts just like the real one. Through a seamless flow of data and advanced analytics capabilities enabled by Philips Health Suite, Dr. Sullivan can connect Mr. Clark's digital twin with intelligence on similar cases and select ablation as the therapy with the best possible predicted outcome for him, both on the short and on the long term. Dr. Sullivan carefully plans the procedure by simulating various ablation scenarios on Mr. Clark's digital twin. This enables her to select the one with the optimal computed result. The chosen ideal scenario forms the basis for real-time intervention guidance. During the procedure, all taken actions, as well as any unforeseen situations, are processed real-time into Mr. Clark's digital twin to redirect if necessary. As a result, Mr. Clark received his treatment at the right time, in the right way, with the best possible outcome. This is one of many potential cases in which the digital twin adds value to the healthcare system. From personalized diagnosis and therapy selection to procedure planning and guidance, tailored to the patient's physical characteristics, medical history, current condition, and future needs. Innovation and you, Philips.
Yeah, I think, thank you very much, Suman, for playing this. I think you would have got a fair idea, BSR and the panelists, on what a digital twin in the healthcare space can actually do. What you are basically trying to do is to characterize the individual, look at what are the best possible interventions for you, and then do that intervention with guaranteed outcomes. So that is something that is at the that is the middle of what a digital twin spectrum that Chetan explained to us. If you move to the left of it, as what is needed in a semi-urban setting, what we could look at is how can we have a set of rules based on which, like for example, if I take an ECG and I do not have a cardiologist there, how do I look at this ECG and have a technician interpret and infer whether the ECG is a normal ECG or does it require immediate intervention? And if so, what type of intervention can be given at the first instance is something that can be done, which is also a form of digital twin. So as I said, digital twin can really spread across. It could be a decision support, guidance-based interpretation to begin with, and it can go to the far end where you have AI, artificial intelligence, machine learning, and what have you built in with multi-parametric, multi-dimensional problems that you're trying to solve. So I think we need to make a beginning in this space, given that we are the healthcare is so concentrated on the cities and we are not able to service the rural population. I think there is enough and more scope in the healthcare space where we can make immediate impact. There are a lot of low-hanging fruits that we can go after and create significant happiness and prosperity for the people.
Sure. Thank you, Ravi. I think if you look at in the video, the heart is shown as my physical heart is here, but the replica of that is created using the digital twin tools. How the data will pump to the virtual, the 3D model heart twin of my heart data, Ravi?
Yeah, you would have seen that. Like, for example, what I do, I take a cardiac CT. Now, a cardiac CT will give me enough information of how the heart is actually behaving. I integrate that with a MR, with an angio, with an MR angio. I would integrate that with an ECG. I would also do a stress test. So basically what you're looking is all the data from multiple modalities are coming in together to characterize how your organ is going to behave.
Okay, so that means the heart, when you pump this data, which is from the different sources, my 3D model heart, which is virtual, using the algorithms, it is able to predict that when you may get a heart attack or when you may get some pain or something like that.
You can get up to a 95-96% accuracy in
Wow,
terms of your
it's
real
wonderful.
heart and your simulated. Yeah, we can
So
do
do you
that.
think
And these
in
are
the
not
next
fiction, they are available today, sir.
Correct, correct. Do you think in the next probably 10, 15 years we will have 130, 140 crore virtual hearts of the people where doctors use it for predictions in India?
You might not need that actually, because these
Okay,
are more where you will start looking at chronic cases. There's a behavior pattern that will start beginning to emerge, and as long as
okay.
you follow the patterns, you can go. What you are saying is into the realm of personalized medicine. I think that is at least about 15 years away, wherein each one of us can get a treatment that is personalized to us, given the body condition, giving the genomics and stuff like that, the basic build of your body. I think to me that is about a decade and a half away.
Fantastic. So I think it's a great example. So probably in future the whole twin of human body will be there. So today maybe only few organs, but tomorrow the physical and the digital, there will be more correlation. Okay. Now let me come to Ben. A little bit I change the sequence. Ben, I think some of the audience has been asking about some standards and integrations of the digital twin. So like Dr. Hari mentioned, it is a physical systems. They have to function well. In a typical city, usually how many twins will be there, okay, and how they talk each other. So, what is that standards you worked out at UK? Can you please share that?
Yeah, sure. So I think a lot of this is a novel space, especially when you're talking about digital twins for cities. And in the UK, we have an aspiration to create something called the National Digital Twin. And I'll talk about a couple of documents that have been published either with the IET or through something called the Centre for Digital Built Britain in the UK that's supporting this aspiration. So if I just share in the chat, first of all, the maturity spectrum document. So this was a paper that we produced with the IET last year in the UK, and it talks about, similar to how Chetan's described the different kind of levels or stages of how you define digital twins and what the types might be. This kind of gives you a little bit of an idea of how we are trying to implement them in the UK. I think it's true that I think everyone wants a digital twin for an asset and a city and the national digital twin at the moment, but they remain a little bit in the future. You know, some of the concepts that we're talking will certainly come to exist, but don't quite exist now. So we've developed something called the maturity spectrum, which goes from element 0 to element 5, and it starts with reality capture and moves through kind of traditional 2D and 3D modeling to connecting of data sets to those models, and then enrichment with real-time data, and then two-way control and interaction, as Chetan was talking, and right through to kind of autonomous operations and maintenance, which don't require humans to be involved in the loop. So I think this is a powerful thing because it kind of gives you some steps, a roadmap. You know, I'm not claiming that it's perfect, but for asset or for infrastructure owners, it allows them to map themselves against these maturity levels and perhaps come up with a plan about how they move through the maturity levels and set some actions and some timescales around that. So I think it's a powerful thing to kind of help this vision become real. The other thing I would like to talk about is with an aspiration around creating a national digital twin or city scale digital twins, there's a lot of issues around security, privacy, and issues of combining data sets within different commercial models. So getting people to share data that might be in the public good, but not necessarily in the company's best interests, traditionally is a real challenge. So one thing that we've done in the UK to try and create some standard approaches and move forward together is create something called the Gemini principles, and I will share this document in the chat as well, so people can read it later. But if I just run through some of those principles, I think it will illustrate how we might create a network, an ecosystem of digital twins that might span a whole country. So, by definition, you are talking about thousands, hundreds of thousands, millions of information models and data sets to be integrated. So I think the definition here of digital twin can be sometimes limiting because this is a developing space. So we need to be open-minded to the real definition. But if I start with Gemini principle number 1, that's it's to do with public good. So the kind of framework for digital twins and the standards must be used to deliver genuine public good. I think we've talked about all the benefits today on the panel, and I think that as principle number 1 is the most important thing. That the reason we're doing this is to make humans happier, healthier, and increase prosperity within our cities. Principle number 2 is value creation. So the digital twins must enable sustainable value creation and performance improvement for the asset and the city that they're focused on. The third principle is to do with insight, and that's that the digital twins must provide determinable insight to the asset or the built environment. The fourth one, and this becomes increasingly important as you integrate data sets and you aggregate information that might present a risk, is security. So the frameworks and standards that are to be agreed in this pursuit must enable security, and they must be secure themselves. Principle number 5 is around openness. I think this is a key blocker at the moment. There's lots of companies selling solutions and tools that perhaps are not as open as they should be. And I think once you move to the scale of having to have different companies and different sections of societies using the data, you can't be reliant on a single vendor. So that the tools need to be open. Principle number 6 is around quality, and I think we've touched on this before. If the data isn't very good in the digital twin, then the decisions you make using it are going to be poor. So there needs to be a focus on data quality within the digital twin. Principle 7 is federation, and I think this is an important one, and the way that we're looking at this in the UK is to create an information management framework based on ISO and international standards. You must allow the kind of connectedness and interconnectedness of different information models and sources, and you must allow them to be federated to create this holistic digital twin. Principle 8 is around curation, and this is about ownership and accountability of the data. So there must be transparency about who owns the data, how it's being used, and how it's being managed and updated to ensure that the quality and accountability is there. And then, as I touched on earlier, principle number 9 is evolution. So I think we're at the start of a journey here. So we shouldn't shut down concepts unnecessarily at this stage. We should be open to the journey that these tools are going to take us on. And I think Chetan's talked about his definitions for digital twin. I've shared the maturity spectrum that's been developed with the IET. I think all these things agree with each other, and it's really important that we don't get too precious about defining ourselves too narrowly in this subject. We need to be open-minded, and I think that for me the best the best analogy I have for a digital twin, having built a few and worked with clients on them, is it's more like the internet than a 3D model. So the user just has a browser that they view the data from. They don't really care how the data in the background is federated or organized, or how it's collected at a sensor level. They just want to view the outcome in a browser. So the real meat of a digital twin is things like HTML and the information management frameworks that sit underneath that automate all the interaction and standardization in a way to empower the user to use the data and make the decisions. So it's a bit more of a philosophical kind of product than a physical product at the moment. And I think by defining it such that we'll be able to unlock the real benefits from it in the future.
Okay. Thanks, Ben. I think wonderful. You highlighted about the Gemini principle, certainly that put a purpose. It's not like just with emotion or a passion we start with digital twin because the technology has come. So I think the 9 principles, what you shared, really provides an extraordinary basis. And also what Chetan mentioned, it is evolutionary. It's a level 1, level 2, level 3. You cannot start just like that. So in a single city, Ben, within 30 seconds, what do you think? How many twins, the digital twins, we can expect? A few million?
I think you can expect a digital twin for every asset in the future. So all our clients are begging us to build digital twins for their assets, and it's much easier for the new build projects to start from scratch, because we have the 3D modeling and the 4D modeling enabled in our workflows now, but we have to go back and map the existing asset and the reality as it is and how it's evolved. So I think there'll be a digital twin for everything at some point in some form, and then we have to, the sky's the limit.
Right. Thank you. I think you answered pretty well. So the core challenges still, I think, will be there. The integration challenges between different physical systems, equally in the digital twins, how that data will be exchanged, and then you will get holistic visibility of the city across all these millions of twins. We need to look at. I think IoT, when it is evolving, probably the standards also will evolve. Thank you so much, Ben. Now let me back to the other important resource. I think One Health. I think Ravi spoke pretty well. With the organs, how we can simulate. Now, the water, very important. I think Bangalore, Chennai, capacity. Vijay, can you tell how the digital twin will help us to bring the responsible consumption without wastage, or distribution without leakage? And then I think it will improve the whole effectiveness of water distribution for clean water distribution.
Yeah, a very important question, Navya. So thanks for bringing that, and that's a bit of a philosophical question too. You know, we saw the various modes of implementation of digital twin here, but I just wanted to, to add to your point, what you have been talking about the water stress. Really, it's now in a situation where it's going out of control, and maybe very recently in 2018, the Niti Aayog, you saw that they predicted almost 6% of our GDP would be at risk by 2030 if we do not manage the resource well now. So that brings a very important point on how are we going to manage water distribution and particularly the drinking water segment, and what are we going to do different, than what is being done till date. You also talked about avoiding the water leakage. That's one thing. But then, the primary expectation of any water network is to basically provide uninterrupted supply of water to all the consumers there. That's the first thing. Of course, it brings in another aspect to that, how we can in fact control the quality of the water. the disinfectants that are being fed there. How do we control the age of water, age of disinfectants, so that there are no byproducts that are getting formed in the system? How do we control the stress in the system? For instance, it's all the more important in the water domain to have right pressure maintained at various points, and the right velocities also to be guaranteed at different points to have a reliable network there. So there are multiple constraints under which you got to ensure the water delivery, and that's definitely where we can think of introducing digital twin to improve several aspects. Then already things are being done in a sense that the water network is getting designed with some of the first principles models. What some of the audience in fact came brought up. There are a lot of hydrological models that are being used today. So hydrodynamic is the primary consideration when we develop this water network. There is a first principles model that is already sitting there. There are models to, in fact, predict the disinfectant, concentration in the system. Because the whole network is a gigantic reactor, so you got to understand that how this reactor basically will allow the disinfectant to react with various organics that are possibly there, the natural organic sources, and also you got to understand that how byproducts are going to be controlled in the whole gigantic sense. So there are techniques out there today, but it's important that we bring all of them together, and at the same time bring in the required data in order to package everything together, bring the machine learning part to the system, and develop a digital twin to the whole network, so that the network guarantees you the quality, and basically helps you to maintain certain parameters under control and do a better job, avoid the leakages, and deliver water to the customer uninterrupted. However, when we do all these things, it is only going to give you a better efficiency achieved. However, if we are talking about resource conservation, it's much more beyond that. It's typically in a distribution network, we talk about delivering water from the reservoir or from the pumping station all the way up to tap. But people sometimes forget about what happens to the water after it leaves the tap. So that's where we got to think about what do we do in terms of managing that water post the usage, and that brings a very important point. Uh, why, sir? We are not getting your voice. You're probably on mute.
Yeah. So what I'm asking is, without digitalizing this whole distribution network, the pipes are there, I think tanks, the reservoirs, and all there. How the data will come to my simulated 3D model sitting in computer? So can you highlight about what is the importance of digitalizing or instrumenting the physical water distribution system, where the data will be pumped to the virtual model in the computer?
Certainly, right, because you cannot have a visibility to the pressure at every point in the whole network that spans for maybe 10 kilometers or 100 kilometers. And then, it's important to have those information be flowing into your system. And then when you think about it, you have to invest a huge amount of sensors to get data from every nodes that are of interest to you. And if you do that, the capex will shoot up, and then we will not be in a position to think about making that project economically viable. But then if you want to use digital twin here, or whatever advanced application solutions you can think of, you can have sensors located at the primary locations or important locations, have few information coming in, but you have hydraulic model overlaid on that, and then the model is going to predict the pressure information at various sources. You have the actual information flowing in, you reconcile with that, so that you will be able to predict a better pressure distribution across the network all over. And that's what essentially the digital twin brings to you.
Okay.
Yeah. And
yeah, probably you can conclude. Yeah. we can get
So,
into
so
another.
yeah, it is trying to continue from where I left. And my point is that one thing is to ensure that we are efficient in terms of the managing the current distribution network, but we got to think beyond it. The beyond this is as some of the things we are getting to know now. We are consuming resource at much faster rate than what it is being produced, and water is also one of those resources. So, if we need to be playing a sustainable game here, it's all the more important to think in terms of circular economy instead of the linear economy that we are in today. So circular economy focuses also on the reuse and reusing the whole water that we are producing, and thereby minimizing the consumption of the fresh resource, and ensuring that the whole game is sustainable in this context. And that's the new piece which we got to bring into the digital twin. Integrate the reuse part also with the distribution part, and treat it as one integral piece and to ensure that water is properly used. Also, water is conserved, and at the same time, water is available for all the users.
Okay, I think very important points you brought out. So one is the physical world without digitalizing it, without making them intelligent. Okay, like Ravi mentioned, maybe some of the wearable devices might send the data about my physical data, or some of the, I think, the tests what is done. And in our case, I think without instrumenting, without having the sensors and Internet of Things type of solutions, like Chetan also mentioned, sandstorms, there are so many, I think, visibility sensors and other silicon sensors and all. Without doing that, I think you don't get the data to be pumped to the 3D model and all. Another important point what to mention is the lean. It's not like I want to have some millions of sensors or millions of devices, right? I think you need to be careful about the physical world also, where you need to have such type of things with a very careful assessment. It's not like just I want to have so much of data on that. So with this, I think we got a pretty good understanding of the digital twin in the healthcare perspective, and also in the water perspective, and in the city, the sandstorms, for example, Chetan has given a fantastic example, and Ben mentioned about very well the 9 Gemini principles. I think that's very, very great, which will really give a great, I think, standard or a principle to the people. Now, let me get into the another topic, which probably even you're all working for your own companies. I request you to give a generic view. Okay, great. We are talking about digital twin. But what are the tools are available? So we are talking about it is a 3D modeling of a human body, or 3D modeling of a water pipe, or 3D modeling of a sandstorm, probably how it will come in a city and all. So what are the tools are available? There are so many tools are there, whether GE or Philips or Siemens, I mean, ANSYS. So could you please share? Maybe I start with Chetan. Chetan, can you have a general thoughts on what all the digital twin creation tools are there? 3D modeling tools, algorithms, all those things. Yeah.
So certainly I can do that. So there are a bunch of tools available, and then I think it will also keep evolving, right? So it depends on what is the twin that is in question. So if, meaning all of you or some of you are aware of the PLM tools where you can create 3D objects, and then there are simulation. So when I say simulation, there is simulation for airflow, simulation for sound, simulation for designing and building IC, the integrated circuit chips. So there are a bunch of things. Now I would like to just highlight one tool that is becoming very, very popular when it comes to cities. It is called photogrammetry, right? So like geometry. So a lot of effort would go in building 3D models of cities, understandably, right? So if you have to create a 3D model of Mumbai or Bangalore or London, it would take forever if you were to go into a BIM model and create that. Now what has happened is technology has evolved in this area a lot, where you can just take pictures from certain points, of course, and then it can stitch a 3D model from this. There is a company called Bentley Systems with whom we really work closely. I'm just giving an idea. There might be many others also. The listeners can Google that, and it's a very, very simple, easy to use extremely impressive tool. Now that's one. And then also about standards, because like when you have the system of systems, there are a bunch of things that interact. And then Ravi will agree with me, healthcare is far ahead when it comes to this. So there are HL7 standards using which you can exchange information. But when it comes to city digital twins, there is this city GML. It's kind of a standard that is evolving to exchange information, move data from the twin, from systems to subsystems. So summarize there are yeah.
The GML is nothing but like a city data model, a pre-canned data model for a city, something like that.
It's still evolving. It's an open standard. Okay. And again, all the open standards are as good as the adoption, right? It depends on how many people actually adopt. So it's still evolving, but there are mature fields like automotive or healthcare or machine-to-machine communication, which are much more mature, advanced, and standardized. But when it comes to city, it is still evolving, but nevertheless, tremendous strides are being made.
Right. Okay.
Yeah.
All right. Yeah. So I think, Ravi, I would like to request you to share your thoughts on how you can create a twin for the heart, a twin for the liver, a twin for different organs. Are there any specific tools for that? I understand even clinical trials they want to do on these, I think, the twins, rather doing on the physical people, which is very harmful. So could you please share some of thoughts on that?
Yeah, there are enough and more tools available. Like, for example, when you let me take a heart, because that's something that everybody can relate to. The entire blood flow of the heart. Look at the heart into two parts. One is an electrical pump. The other one is a mechanical. Is an electrical system and a mechanical system. The mechanical system is basically the entire arteries, which is basically providing you the plumbing. Just the way that you have a water pipeline in the city, it's basically the blood pipeline into your body. So the question is, there are tools like, for example, advanced algorithms, advanced applications are available by which you can map every artery into your body. You can also measure what is the amount of blood flow into each one of them using ultrasound transducers. A normal ultrasound, when I go for a 2D echo, it will basically tell me what is called as a ejection fraction, saying how much does a ventricle contract and how much blood is actually pushed into the aorta. That basically determines the functioning of the heart. So once you characterize the heart both in its physiological form and in its clinical form, using, say, an ultrasound, maybe using a CT scan, maybe an MR scan, maybe an X-ray, you will be able, and using stress tests, using electrophysiological equipment. So basically what you're trying to do is, how do I gather the information from the heart at various points in time? I would also do when I am in a relaxed mode by using the Fitbit, or like, for example, the Apple ECG. You can upload all of those data so you know how the body performs when it is on rest, when it is under stress, and then you can sort of put all of these together, and then you start doing this over a much larger sample.
Okay.
Like, for example, we were developing a chest model for a Middle Eastern country for screening X-rays for detection of lung anomalies. We took about 1 million samples there, and we were able to come with a 99.6% prediction of whether the lung image that is shown to you has an anomaly or not. So basically what you're trying to say, going back to the heart, there are tools by which you can actually characterize the heart for its functioning. You can characterize the heart for the stiffness. You can characterize the heart for the arterial pressure that is being exerted, and all of those. So in reality, it's almost close to a real heart as much as possible. Excellent. And then you start working on the digital model. You look at various interventions, find out which is it that is most optimal, and then you go and do it on that person, because that is the closest that you can get to.
Sure. So I think when I was doing my master's, we used to have CAD/CAM tools to have the modeling of lathe machines or milling machines and all. So is there one single tool, Ravi, you suggest where we can create that 3D modeling of the heart? Okay, algorithms, machine learning will come and sit later. But how I give the shape of the heart in my virtual world, in my machine?
There is something called as a heart atlas.
Oh, heart atlas.
There are organ atlas that are available. Okay. Just the way, as you said, pre-canned data. So you can take that, and then I will take an MR image, and out of the MR image, reconstruct the 3D for the heart using Atlas as a base.
Excellent. Thank you, sir.
Thank you.
Ben, I think you as a neutral man, so you manage some of the digital twins. So I have read some articles. There are so many digital twin creation tools are there, like ANSYS, I think Predix, then Siemens tools are there. Okay, so what are the tools you used in our experience to create these 3D modeling and simulation experiences in the computers? Which tools you used?
Yeah.
Or your team?
So ourselves as a company, we're heavily invested with the Autodesk suite. So we use a lot of Autodesk products to natively author models, and that's the key point for me. I think that the movement and the direction of travel in the UK certainly is a split between where data is stored and where data is authored. So I think the proprietary vendors need to move with us, and we're pushing them to enable their tools to output into standard formats that can be used to integrate with other data sets in a centralized or ecosystem environment. But I think once you've authored the tools in the native environments, and maybe you could use a PLM tool to configure the information, I think that's a standard approach. For me, the interesting bit and an area where I see great strides being made is the visualization of that information that's authored in the native environments. And for me, there's a big opportunity with gaming technology and gaming engines. So the things that Unity and Unreal Engine can do in collaboration with the graphics cards manufacturers, so people like NVIDIA, to integrate the modeling techniques that have been used in Pixar and motion animation pictures. That for me is the real kind of interesting area at the moment. So I know NVIDIA have a product called Omniverse where they're looking to integrate some of these things, and you can basically push your models into these photorealistic 3D game environments, and they have all the physics and light kind of models in there, so you can visualize them like you can on the latest gaming consoles or high-end gaming PCs. And I think some of that has some further application in that we're moving to streaming these games, so the kind of very computer-intensive graphics performance required for the latest games might not sit on a local machine. They might sit on a server. So see things like Google Stadia, where they're streaming, gaming resolution pictures to your TV. You don't need a high-performing computer in your house. I think that for me is an interesting area of development, and we use Unity in-house to develop visualizations.
Excellent. Okay, I think we have 10 more minutes. Probably we will leave this time for Q&A. So I request the audience to shoot the questions, please.
Yeah, we have got some questions. In fact, PSR in the question chat. The first one maybe is for Chetan. We have Jayaprakash Puttaswamy asking us this question, that in many acute problems, actual people living in the city will have more insights on their experience of problems. Do you think involving the community ideas for crowdsourcing or even for data gathering can help in solutioning?
Absolutely. See, cities are kind of, as I said in the beginning, unique organisms, right? So they are always brownfield. Unless it's in Amaravati or the Neom, generally these are cities that existed forever, right? So there is no substitute for local knowledge. And there is every effort that is made to collect data from wherever it comes. The only problem there is authenticity of the data, right? So typically what we do is we certainly open points to collect the data, but then we make sure that it is verified, validated through sensors wherever possible. For example, if somebody says, I'm witnessing a big water leakage, pipe burst, then I would not simply send somebody there. Rather, I would look at a pressure sensor and see if there is really a pressure drop. Like that's a very, very simplified example. But the point is, yes, it is a hybrid thing. So you get information from locals, whoever is the audience, and then there is also something that we overlap with the sensors.
Great. Thanks a lot, Chetan, for that.
Mm-hmm.
The next one is on by Sunil David. He asks us that in a city context, when you have digital twins for various use cases, right, water systems, energy and grid, waste management, traffic management systems, they are all in siloed environments. Is there no integrated view of data? There is no integrated view of data, is what he's saying. So how can this be solved? So anyone from you would want to take this up?
I'm happy to.
Yes.
So I think this is where standardization and the approach that is outlined in the Gemini Principles document, with creating a national information management framework and aligning that to international standards is going to help. But the real problem is, and we're developing principles around this at the moment, and it's new, is that some data gives companies financial advantage. So there needs to be a change, and it's almost a post-capitalist worldview where we have to agree as a democracy what data is useful for the public good, and then legislate so that the companies put that into a data commons that's available to everybody to use. But they still need to be incentivized to be able to retain the data that gives them commercial advantage, and that is the cutting edge, I think. So if we get the commercial model right around sharing data, and it's secure and agreed in a democratic way, I think we can then push forward with standardization, and hopefully these information management frameworks will allow greater or less silos and greater integration of data sets.
Thank you. Thank you, Ben, for that. The next question is, I think we can take one more question. After that, probably we would like all of you to speak about some upcoming business opportunities or new business models that you think can be generated out of this. This is asked by Nishant. He asks us, what could be a digital twin for a hawker who is exposed to the polluted air for 15-16 hours a day? Or on the similar lines, could there be a DSS for decision makers to take informed call on safeguarding key components determining environment?
Super. Yeah, I can attempt, and then Ben, maybe you can chime in. So the question is, we know the problem, right? So the air quality is the simplest to measure. Like all you need to do is kind of have the sensors plugged in at various locations. So we all know the problem with air quality. The bigger question is, what do we do to deal with it? How do we overcome the air quality or the challenges posed by air quality? So as I said, some of the things that the cities are approaching us is, how do we reduce the carbon footprint, right? Not specific to pollution by vehicles and so on and so forth, but overall carbon footprints. So there are cities which have really ambitious plans to go carbon neutral by 2030, 2035, whatever that means. But, the challenge of collecting the data and putting it in a dashboard is not the biggest one. The second part of the question, where the person was asking about decision support, that is the most challenging one. And we are able to tackle these, but then we do not have solutions, or rather we do not have the means to tune the knobs. So for example, if I know in this area there is a lot of nitrogen, particulate matter and so on and so forth, I can tell you it is there, but what to do and how do we reduce that, it's a little far from what technology is able to do today.
All right. And do you have any comments? Otherwise, we probably get into the next and conclude the topic.
Yeah, I would just say that I agree with what Chetan was saying. I think the power of these tools are to free the humans from having to collect that data, so that data comes to them easily and for free, so that they have more time to spend on making the decisions around the interventions. That for me is the real power and the future potential.
All right. So probably my last part of our panel discussion, I request each one to share at least 2 opportunities what the startups or the organizations, the technology organizations can explore and invest in the digital twins area. So, Ravi, you want to start with healthcare, where if I want to start a new company or if I have an organization where I've been already into digital, so which areas and which use cases you think I could invest?
Take for example, if I look at the healthcare burden that exists in India and other emerging geographies, cardiovascular, chronic diseases related to cardiovascular and respiratory, along with diabetes and obesity, these are basically the 4 main, shall I say, the culprits, accounting for almost 10% of the population. And that is a significantly large number. Let me take cardiac as a case in point. We find that there is a propensity, almost 40% of the people living in urban cities have the propensity for some sort of cardiovascular problem once they cross 50 years of age. So is there a way that we are able to screen the population and bring them in for treatment even before it materializes or manifests itself as a cardiac issue, is something that we really need to think about in that perspective, because today's screening in that form does not exist. Now, the question that an story there saying, do I even have the capability of doing an ECG screening? So as I said, if I could have an algorithm which basically has, say, 60,000-70,000 samples of ECG, and then you compare the sample of what you have taken with one of those and give a report out, at least as a first level diagnosis, I think that can go a big way in terms of solving the problem. Because what happens is, if a guy in Mandya were to have a cardiac event, which is about 100 kilometers south of Bangalore, by the time he comes to Bangalore, you have got only an hour, which is called as a golden hour to save the heart in case there is a myocardial infarction. So how do I intervene and give the care at that point there itself, rather than bringing him into the city, is something that we need to think about. And there are more plays around it.
Okay, thanks, Ravi. Water, Vijay, do you think 2-3 examples where the investments can be made for the technocrats?
Definitely, Vaishar. So, in terms of water, what I would like to say is we talked about the resource conservation part here. So, when we talk about resource conservation, it's all the more important to have the recycle and the reuse of water as an important thing here. So, when we go with a system that can kind of accommodate these expectations, it's all the more important that you consider this whole thing as an integrated system. So the more integration you drive in the system, it's a kind of a chain here, and we know that the chain is only as strong as the weakest link that you have, right? And so it's important to understand that functionality of every part is important here. Every process is important in order to protect the system. So the control takes a very high precedence here. But when we talk about controls, it's important to understand that what measurements we have to kind of take a necessary action and control the system, keep it healthy, and keep the whole functioning going. Okay. So that's where the challenges come out. Measurement becomes a very important parameter in water context. There are many parameters which are difficult to measure online, and that's where people can start focusing more today in order to understand and understand the quality of the water and understand the control associated with that particular parameter. And this is one area where I can definitely
Thanks so much. Ben, I think with your experience, how the startup ecosystem in UK got emerged when you are working on digital twins? So what are the areas I think the guys came and worked on?
Yeah, I mean, there are many startups that we're working with it in London and around the UK in this topic, and some of the impressive ones are looking at the actual decisions that need to be made by industry. So I think that the generic challenge in terms of information standardization has to be led by industry and kind of the major players. But decision support for specific challenges could be led by the startup. So I've seen companies look at modeling of steam systems using approaches like visualizations in gaming engines and things like that. Those gaming engines are open source, so there's a low barrier to entry. So I would focus on finding a decision that you think needs to be improved, and creating a solution around that.
Okay, Chetan, probably last two use cases, the use cases. What do you think?
So increasingly we are finding, or at least I sense opportunities in the field of visual intelligence. Because cities, and this is just keeping in the context of cities have enough and more cameras. They are available across in all the possible places. If we are able to decipher this, put enough machine learning, artificial intelligence algorithms around it, and to make sense out of the images that you are getting, that certainly is an extremely interesting area. And I think I'm sure there are a bunch of startups working on it. That's one. The second thing is security, cyber security, and what's happening on that. So these are two areas that I think there can be a very good association with startup and the industry.
Excellent. I think we had a wonderful discussion within the shorter time. With the experience, what you all got, 90 minutes may not be sufficient. So I think we touched upon the urbanization challenges and why the digital twin is very important in healthcare, how the twin can be used in water, how we can use it, and also for the sandstorms and other related, the city administration, how we can use it. Ben shared about the standards and the Gemini principles, really very good. And we also touch upon the different tools to be used and the physical systems, the parallel to the digital twins have to be first properly work, and they should have real, I think, the maturity, and also the data collection mechanism. Unless they are instrumented or digitalized, you don't get the data into the 3D modeling. So there, I think the frugal innovations and lean very important. And then we also talk about the opportunities for the various startups and other organizations. So thank you so much. I think it is a wonderful discussion. One question somebody asked: agriculture in digital twin? Yes, we can, but probably we could respond it offline. Over to Suman. Thank you so much to all. It's a great event.
Thank you, sir.
Thank you. I have very few words to say, VSR, after all of you have spoken about so much into urbanization, future cities, and digital twins. I think it was, I agree that it is a very heavy session to cover in 90 minutes. And, with such a diverse and expert panel, it's may not be, doing justice to each one of you, giving the kind of timelines that we have stuck to. But I think it is very kind of you that you all could join and focus on these kind of crisp and focused topics. I think the audience have also understood the key aspects of digital twins when we talk about implementing it in a city and how various systems coexist in the true nature. I thank you so much, everyone, again for joining us today, and please take care and have a great weekend which is coming up.